Okay, I'm going to build this barometer. It's a design that I created myself, open source. It's got a barometer, two barometric pressure sensors, and a temperature sensor. It's made originally for medical physics to do temperature pressure corrections for radiation measurements. The first three components are three resistors. They're 4.7K, two for a voltage divider, and one for the communications to the sensor modules. And then a Zener diode, or just any kind of low forward voltage diode. Moving on, there are a couple of capacitors, just small 104 capacitors, ceramic capacitors, and a right angle pin header. For the LCD screen, it's a 1602. And then a right angle push button switch. On there as well for the interface. The pressure sensors are BMP 280 and 390. I put a couple of different pinouts on here, so pick the one that matches your sensor. Here I'm using the 280 on the right in J3 and the 390 on the left in J8. But you can see there's a couple other types of sensors with different pinouts that should match up with other headers. So you just pick the one that you need and populate that header with a socket. You could also just solder these in permanently, but I like them socketed so that I can switch them out in case one burns out. Once you get the sockets in, you can put in the Raspberry Pi Pico, and then the charger circuit goes on the back. You can see the pinouts on the top here for the charging circuit, and then make sure it matches up when you solder it in from behind. You'll notice that the charging port is inaccessible, and that is by design. We want it to charge from the Pico instead of from the charging port on the charger. Once you got all that in, then we want to put in the thermometer. So that goes here in the temperature, ground, and VCC on J5. But before you can solder the thermometer in, you need to thread it through the case. So here's the case. I designed it myself, and it's available online. A couple other pieces of components that you're going to need: 1602 display, a 16 by 10 millimeter switch, the 1602 display needs to have the I2C backpack on it. There's the switch and where it solders into, as well as the battery goes into the battery terminals on the charger. It actually would probably be easier to solder that to the charger first before soldering the charger to the circuit board, and then thread the thermometer in through the hole in the case and solder it to the circuit board. I went ahead and just soldered some wires to the display to save room. If you're going to use a regular connector, then you probably have to make a bigger case. And then when you turn it on, it all comes up and works, if you're lucky. To put it all together, you're going to want to screw the circuit board down, and then you can put the button switch button on, and then also secure the battery down with some double-sided mounting foam. Make sure it doesn't rattle around. That can be a fire hazard if the battery is rattling around. I used a zip tie for strain relief on the thermometer cable. And then you can screw the 1602 display in to the case and the top of the case onto the rest of it. You get a thermometer reading, you get a barometer reading, and a temperature pressure correction calculation. If you put your elevation into the software, it will calculate a sea level pressure so that you can check against the local airport. This is the third page. You push the button to get to the next pages. Gives you a battery charge indicator. It's a rough charge indicator. It's not a real great charge indicator because it's just running off that voltage divider with the two 4.7k ohm resistors. And the last page shows you the raw readings from both of the barometric pressure sensors. They just get averaged for that first page. And then also raw reading for the temperature sensor. And that's all there is to it. More information on Thingiverse.